Students, welcome back to TutorHub, your e-classroom on YouTube. So today we'll be discussing the six trigonometric ratios, and we'll have easy and step-by-step discussion on how to solve these problems much easily. But before we proceed, please don't forget to subscribe to the channel, like this video, and please leave a comment so that we can learn more together in our next videos. Okay? So today we'll be discussing the branch of mathematics that deals with the relationship between angles and side lengths of triangles. And that's none other than trigonometry. In trigonometry, we look at its root words or the Greek words where it comes from, which are trigonon, meaning triangle, and metron, meaning to measure. Therefore, in trigonometry, we study the relationship between the sides and angles of triangles and the distances, heights, and directions which we can figure out of these segments or dimensions within the triangles that we are studying. So for example, we have this particular triangle. If we have a right triangle more specifically, and we label the vertices of the right triangle as capital A, capital B, and capital C respectively, then the opposite sides of these vertices will become small letter A, small letter B, and small letter C. So take note, this would be the convention that we will follow on how we label the vertices. Again, the vertices are here, the ones on the corner of the triangles, and the sides opposite of each of the vertices. So this would be the convention that we will do or follow in discussing trigonometric ratios. We call the longest side of the right triangle as the hypotenuse of the triangle. Okay? And the other sides are all or are both called the legs of the triangle. Okay? So that's your hypotenuse, the longest side, and the legs are the two other sides of the triangle. Now, if you have the hypotenuse there and we consider this angle theta of the triangle, then we say that with respect to the angle theta, B, side B, is the opposite side of angle theta. All right? And with respect again to angle theta, side A is the adjacent side or the side beside your angle theta. Right? So you have to take note that you need to consider the specific angle that you are looking at and the sides with respect to it. So again, the hypotenuse is simply the longest side of the triangle, whereas the opposite side is the side opposite to that angle, and the adjacent side is the side beside or near that angle. Okay? On the other hand, if we have angle theta located here, in this particular example, side A becomes the opposite side of angle theta, and side B now becomes the adjacent side. Is that all clear? If you have any questions, write your questions or comments on the chat box. And again, don't forget to like and subscribe to the channel. Now we'll go to the six trigonometric ratios. For sure, you might have encountered these terms in your math classes. Okay, so the six trigonometric ratios are composed of sine, cosine, and tangent. So these three are the three fundamental trigonometric ratios. We'll discuss the other three later. So we'll focus first on the three main or basic trigonometric ratios, and these are sine, cosine, and tangent. So sine is defined as the opposite length of the opposite side over the length of the hypotenuse of that triangle. So we usually provide a shortcut for this where we represent the opposite side as O and the hypotenuse as H. That's why we call the sine function or sine trigonometric ratio as SO, representing sine equals opposite over hypotenuse. Okay, I hope that's clear. On the other hand, cosine is adjacent over hypotenuse, which we represent as A over H, which we usually represent as K, right? K represents 2, cosine is equal to adjacent over hypotenuse, right? And tangent is opposite over adjacent, which is represented as O over A. So we call this as TOA, right? That's why we have SO, Ka, TOA. To represent sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, tangent equals opposite over adjacent, right? Now, what are the other three trigonometric ratios that we should learn? These are cosecant, which is hypotenuse over the opposite side. So cosecant equals hypotenuse over the opposite side. And if you notice, this is the inverse of your sine function, right? It's simply the reverse of your sine function. Then you have your secant, which is hypotenuse over the adjacent side, which is the inverse of your cosine function, right? What do you mean by inverse? It is, so the equation h over a is reverse of the equation a over h for your cosine, right? And you have cotangent, which is adjacent over the opposite, which is the inverse of your tangent function. Okay, so write this down in your notebooks because you will need all these ratios for our lessons and other problems that we will solve later on. So basically, the six trigonometric ratios are sine, cosine, tangent, cosecant, secant, and cotangent. So hopefully by now you're able to remember the equations corresponding to these six trigonometric ratios, right? So here are the steps that you need to follow in order to solve any problems on trigonometry. Okay, so the first one is to label the triangles first. Okay, label the triangle sides. So if you're given a triangle, you should identify the opposite side, the adjacent side, the hypotenuse, and the angles of the triangle. Okay, this is for right angled triangles only, for right triangles. Okay, then for step 2, you choose which trigonometric ratio would you use depending on what is given and what is required. So for example, if you're given the opposite side and the hypotenuse of and you're asked to determine the hypotenuse of the equation and you do not have the adjacent side, the length of the adjacent side of the angle theta, then you might be able to infer or analyze or think that the best trigonometric ratio that you apply is SO, meaning because we have the opposite side and the hypotenuse, then we can use the sine trigonometric ratio to determine the length of the hypotenuse. Is that clear? All right, very good. So that's step 2. After labeling the triangle, you need to analyze which of the trigonometric ratios would you use. Then for step 3, you apply the formula. Okay, so in applying the formula, you use SOHCAHTOA to determine the answer and then substitute whatever is given. And then from there, step 4, you're able to calculate for your final answer. Okay, and you're advised you may use 2 decimal places to report your final answers. Okay, are you ready now for some examples and some exercises? All right, let's see. If you have this triangle with sides 35, 28, and 21, which of these is the hypotenuse? Very good. So the hypotenuse is 35. That's the longest side, and that's opposite the right angle. Then 21 and 28 are simply the legs of the triangle. Okay? And then we need to illustrate or to write or to represent the six trigonometric ratios based on this specific triangle. So remember, sine theta is equal to opposite over hypotenuse. So what's the opposite? What's the length of the opposite side to angle theta? Opposite is 21. So that would be 21. What's the hypotenuse? That's 35. Because 21 and 35 can be simplified further because both of them are divisible by 7, then we can have the final answer for this as 3 over 5. Okay? Now, cosecant theta, cosecant is simply hypotenuse over the opposite side, which is the inverse of your sine function. So that would be hypotenuse, that's 35. Opposite of theta is 21. Okay, opposite of theta is 21. Hypotenuse is 35. This is the opposite, and this is the adjacent. Okay, so that would be 35 over 21. Simplify again, that's 5 over 3. Okay, did you get that? Are you able to follow, class? Very good. Okay, now let's go to cosine. What's cosine? Cosine is adjacent over hypotenuse. So what's the adjacent side of angle theta? Very good. That's 28. And hypotenuse is again 35. So that's 28 over 35. Simplify this further. That's 4 over 5. Okay, we're able to get it? Very good. Okay, then secant. Secant is hypotenuse over adjacent, which is the inverse of your cosine function. So that would be adjacent. Hypotenuse is 35. Then adjacent is 28. So that would be 5 over 4. Very easy, right? So for as long as number 1, you're able to label your triangles. That's step 1. Number 2, you're able to decide or you know what to solve, what specific trigonometric ratio you need to solve. And then you're able to use your formulas and simplify it to the lowest term. Then you have your answers correctly. Okay? Next, tangent theta for the same triangle. Tangent is opposite. Opposite over adjacent. So opposite of theta is 21. Adjacent is 28. So that would be 21 over 28. Simplifying it further, that's 3 over 4. And cotangent, which is the inverse of your tangent function, is adjacent. 28 over opposite, which is 21. So that would be 4 over 3. Right? So that's how simple we can illustrate or represent the 6 trigonometric ratios from the triangle. Okay? Let's have another example. What if we have this angle theta and these sides? Okay? What about if we have alpha? We'll consider angle alpha here, which is, if this is angle alpha, side the leg with the length of 28 will be its opposite side. The leg with the length of 21 is its adjacent side, and 35 will still be the hypotenuse. Okay? Is that clear? Very good. Okay? So in that case, what would be sine alpha equal to? So the opposite side is 28. The hypotenuse is 35. Therefore, simplifying that, that's 4 over 5. For cosecant theta, that's hypotenuse over the opposite side. So the hypotenuse is 35. Opposite side is 28. That's 5 over 4. Okay? For cosine alpha, that's adjacent. Alpha is adjacent over hypotenuse. So that would be 21 over 35. Then we simplify that, divide both numerator and denominator by 7, we get 3 over 5. Okay, did you get it? Proceed. Secant alpha is hypotenuse over adjacent. So this is hypotenuse over the adjacent side. So that's 35 over 21. Simplify it to its lowest terms. That's 5 over 3. Is that clear, everyone? Right. Leave a like button if it's clear and you're able to follow. And let's proceed to tangent alpha. Tangent is opposite. This is opposite, adjacent, and hypotenuse. So that's opposite. That's 28 over adjacent 21. So that's 4 over 3. Cotangent alpha is adjacent 21 over opposite 28. That's 21 over 28 or 3 over 4. Very easy, right? Very good. So that's how we illustrate the 6 trigonometric ratios. Now, let's have another example. What if in this case, we don't know the length of the hypotenuse, but we know the length of the two legs of the triangle? So how do we solve this now? So we use the Pythagorean theorem. Okay, Pythagorean theorem. Are you familiar with this? Okay, so the Pythagorean theorem is c squared, which is the hypotenuse squared, is equal to a squared plus b squared, where a and b are the legs of the triangle. So let's say 27 is a and 36 is b. Okay, and c would be the hypotenuse, which we do not know. So simply we square 27, add that to the square of 36. The square of 27 is 729. 36 squared is 1296. Add the 2, you get 20, 25. Then because this is squared, we'll get the square root of both sides. Then, getting the square root, we now have c equals 45. Okay, so our c, our hypotenuse, is 35. Okay, now that we know the length of the hypotenuse, then we can illustrate, or we can now determine the values of the 6 trigonometric functions or ratios of this particular triangle. So sine alpha, sine theta, is opposite. If this is theta, the opposite side is 36. The hypotenuse is 35, and the adjacent side is 27. So opposite 36, hypotenuse 45. So that would be 4 over 5. Okay, did you get it? Were you able to follow, class? Very good. Then we get cosecant theta. That's hypotenuse over the opposite side. That's hypotenuse is 45. Opposite side is 36. That's 5 over 4 if we simplify that. Okay. Then cosine theta is adjacent. Okay, adjacent. This is the adjacent side over the hypotenuse. So that's 27 over 45. Simplifying that, we get 3 over 5. Okay. Then we get secant theta. That's hypotenuse over the adjacent side. So hypotenuse, 45 over adjacent, 27. That's 5 over 3. Okay. And tangent theta, that's opposite. So this is the opposite side. This is the adjacent side. And this is the hypotenuse, right? So opposite, 36 over adjacent, 37. So that's 4 over 3. Okay. And cotangent theta is adjacent, 47 over opposite, 36. That's 3 over 4. Okay. Any questions so far? Is it all clear? Yes, very good. Then we proceed to our next example. So similar to our previous problem, we have the length of the two legs of the triangle. Now we have alpha. We don't know the length of the hypotenuse. Okay, so simply we follow, or we use again the Pythagorean theorem. C squared equals a squared plus b squared. So A would be 14, B will be 48. So we square that. 14 squared is 196. 48 squared is 2,304. Add the 2, we get 2,500. Then because this is still squared, we need to get the square root of both sides so that we get C equals 50. Okay, right. So the length of the hypotenuse is now 50. Okay. Any questions about the Pythagorean theorem? So it's simply substituting the length or the values of the legs that is corresponding to the formula for us to solve the unknown value. In this case, we solved the length of the hypotenuse. Very good. So we now solve sine alpha. So first we determine the adjacent, opposite, and hypotenuse with respect to alpha. So with respect to alpha, the opposite side is 14. This would be O. 48 would be the adjacent side, and 50 would be the hypotenuse. Okay? So opposite over hypotenuse is 14 over 50. That's 7 over 25. Okay? Then cosecant alpha, that's hypotenuse over opposite. That's 50 over 14. That's 25 over 7. Okay? We need to simplify the values of the 6 trigonometric ratios to their lowest terms. Then cosine alpha, cosine is adjacent, 48 over hypotenuse, 50. So that's 24 over 25. Very good. And secant alpha is hypotenuse, that's 50 over the adjacent side, 48. So that's 50 over 48. So simplifying that, divide the numerator and denominator by 2, we get 25 over 24. It's very easy, right? Right, very good. So again, this is alpha. This would be the opposite. This would be the adjacent, and this would be the hypotenuse. Okay? Hypotenuse is opposite to the right angle of the right triangle. So tan alpha is opposite, 14 over adjacent, 48. So 14 over 48 simplified to its lowest term, 7 over 24. Okay? Then cotangent alpha is adjacent over opposite, that's 48 over 14, that's 24 over 7. Right? Very good. So far, you learned how to determine the 6 trigonometric questions, the 6 trigonometric ratios. Okay? And I hope you learned something today. So for your assignment and for your enrichment, I want you to think about how to, or the length of the sides indicated here. So in this case, you have angle 32, the angle here is 32 degrees. And then you have here your hypotenuse, right? Hypotenuse. Okay, and then you have here the adjacent side. Now that you have your adjacent side, what trigonometric ratio would be best used so that you'll be able to determine or calculate the length of the adjacent side here? Very good. So if you use cosine equals adjacent over hypotenuse. So that's cosine 32 equals adjacent over hypotenuse. What's the adjacent side? Adjacent is x, we don't know. Over hypotenuse is 20, right? So to solve for x is equal to 20 times cosine 32. So I'd like you to get your calculators to solve for this. Okay, press cosine 32, multiply that by 20, you get, very good, 16.96, right? That's 16.96. That's in centimeters. Next, we have this second triangle. In this triangle, you don't know the adjacent side, but you have the opposite side, okay? And this is your hypotenuse. We don't know the hypotenuse, but we have the angle theta. Which trigonometric ratio would you use to solve this problem? Very good. So tangent, okay? So if you have TOA, so tangent 42 is equal to opposite, which is opposite over adjacent. Opposite is 16 over x, right? So if we solve for x, let's bring that here. If we solve for x, we transpose it to the other side. So that would be x is equal to 16 over tangent 42. Okay? Then, get your calculators. Try to solve this, everyone. So if we press our calculators, you have tangent first 16 divided by tangent 42. What do you get? Very good, 17.77 cm. Okay, were you all able to get it? Right, so these are the answers for your assignment and practice problems. And I hope you got it all right and you're able to learn something today. Okay, so again, everyone, thank you students for listening and for learning with me today. I hope you were able to understand the 6 trigonometric ratios in our lesson today. And please don't forget to subscribe in our YouTube channel, like this video, share with your friends, and repeat watching this until you're able to master the topic on trigonometric ratios. Don't forget to leave a comment. If you learned something, you want to know more about other topics, then let me know in the comment section. And again, please come back to our channel, TutorHub, your e-classroom on YouTube. Thank you, everyone. Happy learning, everyone.